All right, this is a recording that I'm doing for section 5.1. Let me share my screen and show you what we're going to be working with. We're going to see the use of the standard normal distribution in StatKey, where you find that. When you're at the home page of StatKey, down below, you'll see these theoretical distributions, and we're going to be using this one here, the normal distribution. And what this needs from us is a z-score so that it can give us our p-value to help us with the conclusion of a hypothesis test. So when you're here, and one of the things I'll show you in lecture is that we are going to have a sample that's going to give us our statistic, but the standard normal distribution needs it in the form of a z-score. So one of the things I've already done is I've done that step here. And again, this will be in lecture of how you run it through the formula to turn it into what is this right here called a z-test statistic. So I'm going to highlight this. And instead of putting your statistic itself into the distribution, you're putting this z-score as its representation of how extreme it is. Now, the other thing you're going to want to do is notate whether you're doing left tail or right tail or two tail. Since this is greater than, this means this is going to be a right-tailed test. And so they're going to ask you for the p-value. Again, we can do that using the old way of the randomization distribution. But now there's a new way that we haven't seen yet, which is the theoretical standard normal distribution. And this is the one that needs z-scores to give you your p-value. And the more extreme that it is, the smaller the p-value. So I'm going to take this 1.25 and I'm going to come here, and there's really not a whole lot to do. You don't need to put your statistic in here. You just need to put in your z-score. But you still do need to pick which is the appropriate tail that you need. Since we're doing right tail, let's click that. And what that does is it turns on the controls. Now this will be your p-value after you put in your z-score here. Now we're putting in 1.25, and you're going to hit OK. And there is your p-value. And you don't need to multiply by 2 since we're only doing just the right tail. So you would come down here and you got 0.106, and then you would continue on with the rest of the hypothesis test. Is it small enough of a p-value to reject? In this case, this one is not. You would not be able to reject the null hypothesis. But let me show you another example here. Again, they're doing here whether the proportion of female would say that divorce is morally acceptable. And here they mention that they want to do a hypothesis test of whether it's more than 60%. And so I already marked down here that that's going to be a right tail test. And I'm not doing every step in here. These are things that we're going to be practicing. So you'll be able to do these parts. But the thing I want to show you with StatKey is when you get to these parts C and D, it's going to ask you to calculate your z-score. So again, we'll do this formula in class to show you how to convert a statistic into a z-test statistic. So what I'm highlighting here is your z-score for your statistic. And again, we've been using in the past anything higher than 2 standard deviations. In this case, 2 standard errors is usually considered extreme, and we should get a small p-value. And that's what the standard normal distribution is you come here, and let me go ahead and just reset the plot. So every time you come here, you're going to want to pick what tail you need. This is again a two tail. Excuse me. This is a right tail. So we're just seeing whether it's greater. And then down here, you're not putting your statistic. You're putting its z-score, and this is to represent its extremity, 3.333. So you'll put your z-score down here, 3.333. You'll hit OK. And this above here will be your p-value, 0.0004, which is super small. So 3 zeros, 0.00043. And this will then let you go on to the next part, which is the conclusion. This is so small. It's smaller than the level of significance. So we would be able to reject and we'd be able to write a conclusion in favor of the alternative. Let me do one more example here. This is one whether they're seen, is there a difference between the proportion for male and female who say divorce is morally acceptable? So this is going to be considered a two-tail test. Let me just mark that here. This is a two-tail test. So the thing about this one is when we get our p-value, we need to make sure that we're going to multiply whatever that number is by 2, since we're doing really a maybe it's less, maybe it's greater. Now, I've already done this part, which you need to take your statistic. In this case, it's a difference of proportions right here, and you need to convert this into a z-score. And there's a formula that I'm going to show you in class on how to do that. But just for the sake of this video, I've already done this. And this here is taking your statistic and converting it into a z test statistic. So you're going to take this 1.38, and you can already tell it's not very extreme since it's smaller than 2. Then when you come here, again, I'm going to wipe this clean and I'm going to go ahead and hit the two-tail. And when you click the two-tail, you still need to make sure that you put your z-score in the right spot. This is 1.38, which would be still to the right. And down here at the bottom, click this and change that to your 1.38. And so this is not quite your p-value, but it's what you need to multiply by 2. So essentially you're taking all this area to the left and all this area to the right and putting that together, you get your complete p-value. So 0.084 right here, this is going to be 2 times 0.084, which is going to end up leading to quite a large p-value. So if I get out my calculator, 0.84 times 2, 168. And then you would be able to use this 168 to see that it's not significant since it's such a large p-value. So you would say, do not reject null. We do not have enough evidence for the alternative. And here's another one that's really essentially the same thing. You'll get your z-score. And again, this is what you're putting into the standard normal distribution to get your p-value. But you'll see some examples in the homework that are very similar to this. So you'll need StatKey to put your z's in there to get your appropriate p-value. All right, but I hope that helps.